So this problem says find the final pressure of a gas at 150 Kelvin if the pressure of the gas was 210 kilopascals at 120 Kelvin. And so, of course, this problem will use Gay-Lussac's law. So if we do PV over N times T, Gay-Lussac's law relates pressure to temperature. So P1 over T1 is going to equal P2 over T2. And one thing to note when using Gay-Lussac's law is that your temperature must be in Kelvin. And so in this problem, our temperature is already given in Kelvin, 150 Kelvin and 120 Kelvin. But if it's not given in Kelvin, you should convert it to the Kelvin scale because gas laws cannot be used when you have a negative temperature value. So let's go ahead and start writing out our variables to find the final pressure. So we're looking for P2. P2 equals question mark. And let's see, we must have P1, T1, and T2. So I just like to write out all my variables. Find the final pressure of a gas at 150 Kelvin. So that must be our final temperature at 150 Kelvin. If the pressure of the gas was 210, so that's our initial pressure, 210 kPa, at 120 Kelvin. So our initial temperature, 120 Kelvin. So our units are consistent. We have Kelvin for both of our units of temperature, and it doesn't ask for a specific unit of pressure, so we can give our pressure in kilopascals, which is what it will come out as. So let's just go ahead and substitute our values in. P1, 210 kPa over T1, which is 120 Kelvin, equals P2, which we're looking for, so we're going to put X, over T2, 150 Kelvin. Okay, so now that we have our problem set up, we're going to need to cross multiply. So 210 times 150 will equal 120 times X. So I'm going to rewrite that out, leaving out my units this time. 210 times put a parentheses, 150 equals 120X. Okay, and now I can combine these terms together, 210 and 150, so let's get out our calculator. 210 times 150, that gives me 31500 equals still 100 and, let me move that out of the way, 120X. And then last but not least, I just need to isolate X. Currently I have 120 times X, so the opposite of multiplication is division. So I'm going to divide by 120 on both sides. So now, moving my work up here, I end up with X equals this divided by 120. Let's take this back, divide by 120. I got 262.5. Okay, so now let's figure out some units here. Our X is of course our P2, our final pressure, and our initial pressure was given in kilopascals, so our final pressure will also come out in kilopascals. And last but not least, we need to round to appropriate significant figures. 150, that 0 is not significant because there's no decimal point, so this has two significant figures. Two significant figures here as well, and two significant figures here as well. So our answer needs to be rounded to two significant figures. We look at the 2 to determine if the 6 stays a 6 or rounds up to a 7. Since 2 is less than 5, it says 2, 6, and then we fill in the place before the decimal with a placeholder 0. 260 kPa is our final answer for P2.